Okay, in this video I'm going to solve an example problem, one very much like a homework problem. And here it says, can the following 8 Class C networks be grouped into a single /21 CIDR block? Explain. And so here we have 8/24, or that is 8 Class C networks. A /24 is a Class C. And they are the 68.0, 69.0, 70, 71, up through 75.0. And the question is this a valid grouping? And so to be a valid CIDR /21 block, the ID of that block must have all zeros past bit 21. Okay? The normal thing, the subnet ID or the network ID has to have all zeros to the right of the rightmost n bit, the rightmost network bit. And so bit 21 is the 5th bit in octet number 3. Okay, so bit 21 is here. Here's octet 1, octet 2, and here's octet 3. And here's octet 4. Okay, here's octet 1, 2, and 4. And then here are the bits in octet 3. Okay, and so we have 8, 16, 17, 18, 19, 20. The 21, bit number 21 is the 5th bit in octet number 3. Okay, so here's octet number 3. So to have zeros in bit position, so we've got to have zeros from here on out. Okay, and so let's see if that's what we have. It turns out that if you want to have 3 zeros at the end of a binary number, that number must be a multiple of 8, which is the bit position, the placeholder value of the bit just to the left of those 3 zeros. So we have the 1's place, the 2's place, 4's place, the 8's place. Any multiple of 8 is going to have 3 binary zeros at the end of its binary representation. And so to have zeros in the bit position 6, 7, and 8, the value in the 3rd octet must be a multiple of 8. And in this case, starting at 68, 68 is not a multiple of 8. And so this is not a valid grouping of 8 Class C's into a single CIDR block. Okay? Again, if we look back here, if we're grouping 8 of them, we're going from /24 to /21. 8 together means that we're going to have 3 bits, which means we're 3 off on our slash number back to a /21, and we've got to have a multiple of 8 in this spot right here if we're going to use this as our starting spot. We can also just simply look at the 68 and ask ourselves, do we have 3 zeros there? And so 68 is 64 plus 4, 0 in the 128's place, 1 in the 64's place, the 32, the 16, the 8, and here's a 1 in the 4's place. And that's in those last 3 bits there, which are beyond the 21 bits of the network address. And so that's not a valid network ID. Okay. What we can do also is look at the values 68, 69, 70, 71, 72, 73, 74, and 75, the 8th one, and look at their binary representations and ask ourselves, do we count 8 in binary in these last 3 bit positions? And 68 is 01000100. And so 69 is, oh boy, 69 is 01000100. Doesn't like to write about half the time. I don't know what's wrong with it. 01000110. I'm just counting by ones in binary. 0111. 010010. 100. So I'm counting by ones in binary here. 1010, and finally 01001011. And so the question is, if I start at 68, am I counting from 0 to 7 in the last 3 bits there? And the answer is no. Okay. However, you'll notice that if I had started at 64, which does have 3 zeros, and gone up through 71, it would have worked. And had I started with 72 and gone up to 79, it also would have worked. I would have been counting from 0 to 7 in the position where the S bits are. Okay, so I guess I hope this helps.